Hey everybody, welcome to InterviewBlog. In this video, we will be covering the question move elements to n. The question gives us an array of integers and a target value, and it wants us to move all the target value to the end of the array. The question also wants us to maintain the relative order of the non-targeted elements. For example, in this case, we can see that the given target element is 0. So we have to move both the zeros to the end of the array. And now the relative order of these non-targeted elements should be maintained. That is, first in my array, I should have my 1 followed by 3 and followed by 12. So my function should return this array as my answer. So to solve this problem, I will be using simple two-pointer technique. My first pointer, I, is going to traverse the given elements of the input array one by one. And my second pointer, index to be updated, is going to keep track of the index that needs to be updated. So initially, both of these pointers would be pointing to the first index, that is 0. My approach to this problem is that while traversing the given input array, whenever I find a non-targeted element, I'm going to swap it with the index that needs to be updated. That is, I'll be moving these non-targeted elements to the front of the array. So whenever I find a non-target element, I'm going to swap it with the index that needs to be updated. Now, since we have already updated the index to be updated, we need to increment the index that needs to be updated. So let us now see this example. So let me quickly erase this ith pointer and make it point to the first index. Now, this ith pointer is going to traverse the elements of the array one by one, and the index to be updated pointer holds the index of the first target element. So initially, both these pointers would be pointing to the index 0. And now I'll be checking if the element that is present in the ith index is not a target element. But here we can find that the element which is pointed by the ith pointer is equal to the target. Hence, we just have to update our ith pointer. That is, we need to simply continue our traversal. So now we'll be checking if the element that is present in the ith index is not equal to our target. And here, since 1 is not equal to 0, we need to swap it with the first index to be updated. That is, we need to swap the value that is present in the ith index with the value that is present in the index to be updated pointer. So we will be swapping, and the resultant array would be 1, 0, 0, 3, and 12. So after swapping, since the value that is present in the index to be updated is already updated, we need to increment the index to be updated pointer. That is, index to be updated will now be incremented and it will hold the value 1. So let me just move this array here. So now I will continue to traverse the input array. Now my ith pointer will point to the index 2. I'll be checking if the element that is present in the ith index is not a target element. But here, since 0 is equal to the target, we simply continue the traversal. That is, we'll be moving our ith pointer to the third index. So now we will check if the element that is present in the ith pointer is not a target element. Here we can find that 3 is not equal to the target. So we will be swapping the element that is present in the third index with the element that is present in the index to be updated, which is 1. So my resultant array after swapping would be 1, 3, 0, 0, and 12. So after the swapping, since the element at the index to be updated pointer is already updated, we need to increment the index to be updated pointer from 1 to 2. So now I will again be continuing to traverse the array, and I'll be reaching this fourth index. Now I'll be checking if the element that is present in the ith index is not a target element. And since 12 is not a target element, we need to swap the element that is present in the ith pointer with the element that is present in the index to be updated pointer. So our resultant array would be 1, 3, 12, 0, and 0. So now we can see that we have completed traversing the entire array and we have found the answer. That is, all the target elements are moved to the last positions of the given input array. So hope you understood the solution. Let us quickly see another example. So in this example, we can see that the given target element is 1, and hence the element that is present in the first index should be moved to the last position of the given input array. So initially, both of these pointers would be pointing to the first index, that is 0. So now I'll be checking if the element that is present in the ith index is equal to my target element. If the elements are equal, then I will continue to traverse the array. And when they are not equal, I will simply swap the ith index with the index to be updated and increment the index to be updated. So in this case, 0 is not equal to 1, and hence I'll be swapping the element that is present in my ith index with the element that is present in the index to be updated pointer. But we can see that both my index to be updated pointer and the ith index are equal to each other. Hence, it means that we are actually not swapping any elements. So after the swapping is done, we will be having the same array, that is 0, 1, 0, 3, and 12. So after swapping, we will be incrementing our index to be updated pointer from 0 to 1. Then we will continue our traversal. So I'll be moving my ith pointer from 0 to first index. Now I'll be checking if the element that is present in the first index is equal to the target element. And since both of them are equal, I will simply continue to traverse the array. Now I'll be checking if the element that is present in the ith index, which is 2, is equal to the target element. Since 0 is not equal to 1, we will be swapping the element that is present in the ith index with the element that is present in the index to be updated pointer. So after the swap, the resultant array would be 0, 0, 1, 3, and 12. Now we will be incrementing our index to be updated pointer from 1 to 2. Then we will continue to traverse the input array. So I'll be moving my ith pointer from second index to third index. Now I will check if the element that is present in the third index is equal or not equal to the target element. Since 3 is not equal to 1, I will be swapping the element that is present in the ith index, which is 3, with the element that is present in the index to be updated, which is 2. So I'll be swapping 1 and 3, and my resultant array would be 0, 0, 3, 1, and 12. So after the swapping is done, I will be incrementing my index to be updated pointer from 2 to 3. So now I will continue to traverse the array, and I will be incrementing my ith index from 3 to 4. Now I will check if the element that is present in the ith index, which is 12, is equal or not equal to our target element. Since 12 is not equal to 1, we have to swap the element that is present in the ith index with the element that is present in the index to be updated. So our resultant array would be 0, 0, 3, 12, and 1. So as you can see, we have completed our array traversal, and our target element, which is 1, is present at the last position of the given input array, and hence our function should return this array as the result. So hope you understood the solution. Let us now analyze the complexity of our solution. So the time complexity of our solution tends to be big O of n, where n is the number of elements in the given input array, and the space complexity of our solution tends to be big O of 1. So why is our time complexity big O of n? Since we are using this ith pointer to traverse the entire array, we are visiting each and every elements that are present in the array, and hence the time complexity tends to be big O of n. So why is the space complexity constant? Since we are using just pointers and swapping the elements of the given input array in place, our space complexity tends to be big O of 1. So hope you understood the problem. Let us now implement it in code. All right. So we got our move elements to n function defined, which takes in an array and a target element. So as discussed earlier, I'll be using two pointers, that is the ith pointer that is going to traverse the input array. So I'll be saying for I in range len of array. So this ith pointer is going to traverse the input array, and I'm going to have another pointer, that is index to be updated pointer, which points to the 0th index of the given input array. So now while traversing the array elements, I'll be checking if the element that is present in the ith pointer is equal to the target element. In this case, I will simply continue my traversing. And if the element that is present in the ith pointer is not equal to the target element, then we will be swapping the element that is present in the ith index with the index to be updated, and I'll be sending the array. So we'll write the swap function above. Swap, which takes in two index t and j and an array. So inside this swap function, I'll be saying array of 5, comma, array of j is equal to array of j, comma, array of I. So this swap function actually swaps the elements that is present in the ith index and index to be updated index. So after swapping, I will be incrementing my index to be updated. So this will be my solution. So our solution has a time complexity of big O of n, where n is the number of integers in the given input array, and a space complexity of big O of 1, where n is the number of elements in the given input array. So hope you understood the solution. Let us now test our solution. So I'll just copy our solution. So this is Leetcode problem number 283, which says move zeros. So the only difference between our problem and this problem is that here the target element would always be a 0. So I'll be pasting our solution here. And I'll be saying return move elements to end of nums comma 0. Since the target is always 0, we are passing 0 to our function. So let me just run our solution. So yes, let us now submit our solution and check if it passes all the test cases. Our solution got accepted. Hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.